This is Christina Anderson from Wisconsin Land & Water, and I'm excited today to have Kevin Masarik join us from UW Extension, Stevens Point, for understanding groundwater quality through a private well monitoring program. So Kevin will provide an overview here of groundwater monitoring approaches, incorporating lessons learned from his work with communities across Wisconsin. He'll provide examples of different monitoring approaches. Much of the presentation will focus on key strategies to consider when designing and implementing groundwater monitoring program to fit local needs and future concerns. With that, Kevin, take it away. Thanks.
Thanks, Christina. And I apologize. I'm dealing with a little bit of a cold, so I'm hoping my voice holds out here. As stated, I work for UW Extension as a groundwater education specialist. For the last 15 years, I've been working with local communities to do groundwater, kind of private well water monitoring programs. And what I'd like to share with everybody today is kind of some of the approaches that we've used and developed over time, and maybe some lessons learned in terms of what to look for or what to do and what not to do. If we look, here we go. So if we look, I'm not sure how many people have joined us in previous sessions. Obviously, groundwater is the thing that we're focused on, but because it's a resource that's underground and we can't see, we need windows into that resource to be able to characterize it for various things, including water quality. So groundwater is always moving. Obviously, recharge, snowmelt infiltrates, soaks down into the ground, gets to a point where all the empty spaces are filled with water, and that's our groundwater. And most people, most communities use wells to pull water out of the ground and into their homes. And obviously anything that we do in the land surface has the potential to impact that resource. One thing that I try to get across to communities is that groundwater is a local resource. So the more windows we have into that resource, the better we're able to characterize and understand it. There's also a difference between public and private wells. Public water supplies are regularly tested, regulated by drinking water standards. We heard a little bit of that last week from the DNR folks, if you joined on that webinar. Private wells, on the other hand, are not required to be regularly tested. There are some requirements for at the time of drilling, maybe anytime the well is inspected or there's well or pump work done. There's some small or a few required tests at that time. But generally, the homeowners aren't required to take corrective action if anything is found wrong. So they really are their own water utility manager. And one thing that we try to do through our outreach programming is not only collect the data, but help them understand what their role is and make them feel comfortable with testing and interpreting those results. So when I get calls from communities, there's some frequently asked questions that I get when people want to develop a groundwater well water testing program. And the first is, how much does it cost? When can we get started? And are there grants or other funding available to cover the costs? And I might disappoint people here by not having clear answers to these questions. When it comes to cost, it really depends. When it comes to when can we get started, that also depends on a variety of factors, including what your program or monitoring plan looks like. And then, unfortunately, when it comes to grants and other funding available to cover costs, those are oftentimes few and far between, or they're pretty modest and not able to do very extensive testing. They might be enough to get people started. The Department of Safety, or not Department of Safety, but Department of Health Services generally has grants every year that they offer that allow people to maybe get started on a groundwater monitoring program, but it's not something that's able to sustain a groundwater program long term. And that's where communities and counties, maybe need to lay some groundwork well in advance to gain the support to do an extensive monitoring program. And I hope to provide some examples of counties where they've been successful at doing that. I'd like to ask the question, why start a groundwater monitoring program? And if there's anybody on the call that is is thinking about it for their community, I guess I'd like to hear, in the next 10 to 15 seconds, maybe use the chat box to write why you're interested in starting a groundwater monitoring program for your community. I'd like to get some feedback on what are the county's motivations at doing these programs. So if you're on the call and you wouldn't mind, sharing your thoughts on what your goals or your interests are, that could be helpful as I move through the presentation.
I'll also just remind folks in this break while you're thinking about it and maybe entering your chat that if you are on a phone, we make sure that you're muted, not only on our GoToMeeting, but also on your telephone. And then Kevin, it looks like Shannon has replied to you.
Thanks, Shannon. So Shannon states that increases in nitrate levels maybe have prompted some concerns at their local level. And interest in groundwater monitoring. That's definitely one that I've heard before. Here's another one from Chase. Trend analysis of water quality within the county, public pressure for more data, and those are those are the things that I'm hearing a lot. People concerned about groundwater quality but don't know that they should be monitoring their well regularly. So already I'm hearing or seeing some different goals for different counties or communities, between the need to collect more data, maybe to try and understand or characterize how it's changing, but also a need to just simply educate that audience about their role. So I appreciate everybody sharing their thoughts there. Moving forward here, and I'm trying to, there really is more than one monitoring approach, and I don't want anybody to think that the information I share is the only way to do it. There's no one-size-fits-all solution, because every community is different depending on the soils, the geology, the land uses, or the different industries that you encounter, where people live in terms of the density of development, access to funding and staffing resources also may determine what you're able to accomplish in the time or the resources you have, whether it's funding or staff. And as we heard from the people that shared their comments, each community probably does have different reasons why they're interested in approaching this question. So these are the things that I think would be good to think about, either before meeting on this at a local level, or some questions that you'd want to get out of local leaders or local officials that might be encouraging you to do something, or people that are looking to do this, and to try and help encourage why it's important to do it. It's good to have answers to these questions. Sorry about that. So the questions I think that are important are, what is it that you want to learn or accomplish? Are the interests at a county-wide scale, or are they site-specific? And what I mean by that is I often get comments about, well, we want to know in the area around a proposed CAFO or a landfill, is the water quality changing over time? And those questions are very site-specific. It wouldn't necessarily benefit from a county-wide strategy to look at groundwater quality. If your question is so site-specific, it probably is better off using a different approach. It may need actual monitoring wells that are installed to look at those questions rather than a broad look at county-wide groundwater quality. Other things is what information exists already. Maybe there is great baseline data available that people are currently unaware of that could be tapped to, really propel a groundwater monitoring program forward. And then the other question is, what is motivating people's concerns or interest? And there too, Sometimes there's a local issue that's really motivating people's concerns, and one strategy is not maybe going to get you the answers you want if your answer or your question is very specific. One place I mentioned is if you want to look and see what information is available, one place that I would encourage people to start is the Wisconsin Well Water Quality Viewer. The link is provided here. You could also just search in a search engine for Wisconsin Well Water Quality Viewer, and it should lead you to this page. I'm not going to demo it today. If communities are interested in a demo, or yourself, you want a tutorial on how to use it, feel free to call, and I'd be happy to spend 5 minutes on the phone with you going through some of the features that might not be readily apparent to the average user. Other things to consider or try to determine before starting a groundwater monitoring program are to not only define the goals, but also build consensus around what those goals might be. Without consensus, especially in counties or areas where groundwater monitoring might be a little contentious, or you're trying to use that data to understand specific questions about trends, if you don't have consensus about what the goals are or what the strategies are to use that data, you might collect the data and then it will be disregarded. So I think it makes sense to spend some time, maybe even with a facilitator, facilitating a meeting about establishing the goals for a groundwater monitoring program. And I've provided some examples here of what those goals might be. Some might be very simple, innocuous: build knowledge to inform groundwater management, educate rural landowners on owning, testing, and maintaining a well. Those are things that are generally, kind of non-controversial, that people should be able to agree on. When it comes to, we want to establish a baseline understanding of current groundwater quality. That's where sometimes people get a little resistant, or maybe, a little scared or fearful, in a sense that it's going to point out to problems that they might know or kind of understand could be issues, but don't necessarily want to know and get that information out, because it might make people look bad, or it might make people feel bad, in a sense. And then the question of understanding how groundwater is changing over time, or looking at the idea of trends, that's another goal, but that also requires kind of laying the groundwork for that baseline data first, before you're going to be able to understand how it's changing over time. So these are all good goals, but it really helps define what your objectives and what that groundwater monitoring plan ultimately will look like. The other thing people would need to spend some time thinking about is what do you want to test for? And nitrate is one of them that's probably most common and people think most about, because it's influenced by land use activities. There are health concerns associated with it. It's generally a fairly inexpensive test. So it's something that's easy to do, but gives you a lot of great information. Other areas might have specific geologic concerns that would also be good to test for and try to characterize or understand. It's obvious that these tests have costs or fees associated with them. And if you're limited on funds, or you're relying on homeowners to do the testing, cost is always going to be an issue. But the more things you test for, the more information you're going to collect. And there's often many different benefits from including multiple tests, besides just maybe one key test. It affords you some opportunities to do some different things, or learn some different things that maybe we didn't have a lot of information on already. The dollar signs there just kind of indicate, general cost, which ones are less expensive, which ones are more expensive. And it's not that every well would necessarily need to do maybe pesticides or pharmaceuticals and personal care products. Maybe that would be a next step after initial testing of something like nitrate, which would give you some information to really target wells for those more expensive testings. The other thing that I would encourage counties or local agencies to consider is, if you do a groundwater monitoring program, how are you going to store or manage that data? It's not unusual. We've had it come up recently where we've had open records requests, and you kind of want to know what your response is going to be before you would get a records request for data. Private well owners sometimes, there is sometimes an expectation for privacy, and that information is shared with, and you never want to overpromise privacy ahead of time. If your county or your legal department determines that anything you collect is open access or open records, you don't want to be in the position of having promised privacy to the well owners who participate, and then have to kind of go back on that promise. Also give some time to consider who's responsible for maintaining and ensuring that quality long term. In the format and the programs used, we've ran into this where the database that we've used to manage it is kind of gotten out of date or unsupported, and we've had to find ways to kind of migrate that over to new or updated platforms. So those are all things that take time and are important to consider. Also, when you're looking at what to collect, what information to collect for each sample, it's important that each well, we know when it was sampled. If there's a Wisconsin unique well number, that provides a unique identifier that can be linked to a lot of important well construction information. If you don't have a Wisconsin unique well number though, well address is absolutely critical. Unique well number is great to have, but the well address is absolutely critical to be able to kind of deduplicate well samples. Without that well address, you don't know if there's a mistake in the database where records were entered more than once, or somebody submitted a treated sample and a sample from their well. Without that kind of well information or some additional information on those parameters, it might be difficult to know exactly what that data represents. And then spatial coordinate, geocoding is one way that you can maybe use the well address to get that spatial coordinate. That doesn't always work if the address was entered incorrectly, or for whatever reason the systems don't mesh in terms of how they communicate together. It's oftentimes the case where you have a well address and it cannot be identified by a spatial coordinate 100% of the time. So the more information you collect ahead of time, the better you're going to be able to use it in the future for understanding some key questions. And then for each parameter, you obviously want that water chemistry result, but it's also important to know, limited detection of the equipment, because a lot of the samples might come back below the limited detection, and knowing what that is important for doing statistics and other evaluation to that data. So getting into 3 examples of how we've approached groundwater monitoring. UW Extension, who I work for, has been doing private well water testing programs for a long time. These programs are basically open to anyone. You might advertise in one town, 1 or 2 towns, maybe it's countywide, where you kind of get the word out that this testing is happening. Anybody can participate, but the homeowner has to pay for the cost of the sampling. The homeowner picks up a bottle from a local location, takes it home, collects the sample, and brings it back to someplace locally. Those samples are then driven back to the lab here at UW-Stevens Point, where they're analyzed and the data is packaged together for a presentation that we give in that community. These programs, most are going to have some entity that's responsible at the local level for arranging sample bottle distribution, collection, and recruitment. And recruitment is usually some sort of direct mailing to the targeted area. That is definitely the best approach. The places where you rely solely on maybe print or radio media generally don't get as good participation as a direct mailing would, where those people have all the details right there in front of them. For these programs, pre-registration definitely works well. And in a well-advertised program, we might expect about 10% of households in a targeted area to participate. And that might not sound like a lot, but over time, we've learned a great deal about Wisconsin's well water quality by doing these programs. And 10% gives us a pretty good idea of what we'd expect for those areas. And if you come back to those areas over time, you're going to increase the number of wells that have been tested. These data sets collected through the UW extension model really are what have laid the groundwork for the well water viewer. So any programs that we do through UW extension here do feed to growing that database and painting a more detailed picture of well water quality in Wisconsin. Another example that we've done recently is with Portage County. And I want to thank Portage County, specifically Jen McNally, who was really instrumental in helping arrange that at the local level. This relied on more of a gridded sample design approach, where the county was divided into 2 by 2 mile square grid cells. There's good points to this strategy in that it allows for kind of equal distribution of sampling across the county. But some downsides to it are that it doesn't necessarily result in a well or every cell being sampled, because everybody's county is probably different. Where you have maybe a state forest or a county forest or maybe a large wetland complex, that there's not going to be anybody living in those areas with a well that can be sampled. So on the map that you see on the screen, you'll notice that each grid where we received a sample has a nitrate value associated with it and a color. And then the white cells are those cells where, again, there's a large marsh complex or forest complex where we weren't successful at obtaining a sample because there just wasn't any people or households in those areas to provide that access point. This type of approach has more upfront development at the local level. Maybe it's the county, or maybe it's an entity like us who they contract with to determine who gets that letter and who participates. There's definitely more upfront work on this type of approach than there would be for that UW extension model that we talked about previously. And then in this model, because you're trying to target specific areas or specific wells, the cost generally is not incurred by the homeowner. If you truly want a random sample and want those people that you contact to participate, it's going to be much more successful if you have funding to cover the cost of that sample rather than ask them to pay for it on their own. Recruitment strategy here is usually some sort of direct mailing. There's usually a follow-up for those people that don't respond, and if they don't respond after the second one, then you have to recruit somebody else from that same grid cell to try and collect or fill in that grid as best as possible. If you're relying on the homeowner to sample and maybe drop that bottle off somewhere locally, there's a little bit of a cost savings there. But if you want staff, if you really want the data integrity to be able to say that these samples were collected by staff, then that's obviously going to add to the cost of that overall program in terms of their time driving around the county and the additional time needed to line up with the homeowner when they can come out to the property and take that sample. So that definitely is going to add some cost and probably a little bit of a length to the project if you're relying on staff to do that sampling. These are some of the results from that Portage County study. The nice thing about having spatially distributed across the county is it gives you some idea of what are the major contributing factors to groundwater quality. And the factors that we're looking at here are trying to explain the differences in nitrate variability. And what we determined when looking at all the different land uses was that agricultural land, as well as the soil drainage classification, were the dominant drivers between nitrate differences in Portage County. So we have agricultural land cover in the upper left, soil drainage on the upper right, and then these graphs on the bottom are showing nitrate as a function of soil drainage classification on the left, or the y-axis, and percent agricultural land within half-mile radius of the well on the lower x-axis. And the dot, is situated on that graph to show, the characteristics of the soil and the percent land cover, and then the color of the dot is corresponding to that nitrate concentration. And what we see is that as the percent of agricultural land within half-mile of the well goes up, and as the soil becomes more well-drained, nitrate values tend to increase. If we look at the same plot on the lower right, it's the same information, only that x-axis is showing nitrate as a function of percent forest land cover within half-mile radius of the well. So it's kind of the inverse relationship of what we saw with agricultural land cover. And it showed that once you get above about 50% forest cover around that well, the nitrate concentrations really start to drop. So forest cover, forest cover is good if we're trying to understand the impact of different land covers on groundwater with respect to something like nitrate. We were able to even go further and use this data with a multiple linear regression model to get at specific agricultural land covers. And it found strong evidence of positive relationships to potato vegetable land. There was strong evidence to continuous corn land cover, and there was weak evidence to show kind of the impact of dairy, typical dairy land, which would be a rotation that's common on dairy farms. One downside to this gridded approach, though, is that it can overlook certain constituents as well. So if we look at all the wells in Portage County that we see here on the left, the graphic on the left, the wells in blue are the ones that were sampled as part of this project. And you'll notice that there's large clusters of wells in some of these grids, but there's only one well sample that was collected. So while we were pretty good at characterizing groundwater quality with respect to various land covers in Portage County, we had good equal distribution across our grids. If we look at the graphic in the upper right, what you see is that the dots are really clustered. When we look at the normalized septic count on the x-axis, the dots are really clustered on the left-hand side of that graphic, which is really pretty rural areas where there's not a lot of small lot sizes. But if we look at where most of the wells are located in Portage County, they are located in those areas where there's a high density of private wells and septic systems in a small area. So while I think this gridded approach was good for understanding kind of general groundwater quality across Portage County, it might not necessarily give us a good picture of what is groundwater quality like where most of the individuals relying on private wells actually live and are getting their water from groundwater. So that was something we learned from this gridded approach, was that it really maybe gave us an underestimate of groundwater quality, or an inability to really characterize groundwater quality in those areas where most of Portage County's population on private wells is occurring in. If we look at the third example, here we're talking about Chippewa County, and this is a county that even before we got involved had a really strong history of groundwater monitoring. They did an extensive survey in 1985, 2007, and 2016. We were fortunate enough that they contacted us in 2016 to help them out with doing a sample of 800 wells across Chippewa County. And here it allows for maybe a slightly different design in that you can look at, instead of a gridded approach, you can look at doing some sort of stratified sample approach where you're deciding who's going to participate based on certain criteria. Maybe that criteria is geology, which you know would have an impact on water quality. Maybe it's land cover. Maybe it's looking at the previous example where we underestimated wells in heavily populated areas. Maybe we look at septic system density or well density as a stratification classification that we want to look at. In this example, again, like the previous one, the cost generally is not incurred by the homeowner. We want to target in our sampling approach, if we want to stick to our sampling design, we want to target the wells that we want to target, and providing that incentive or that fee exempt testing is really probably the best way to encourage those homeowners to participate. Recruitment is going to be very similar: direct mailings, follow up with non-responses, and then recruit additional participants if initial well was unsuccessful. And then the cost of sampling is a function of both the homeowner or whether the staff is collecting that sample. Here's some of the ways that we were able to look at that data in Chippewa County here. We look at, if we want to look at it as percent of agricultural land use, we can kind of clump those samples into different boxes. The different boxes would allow us to kind of see the relationship of agricultural land cover to nitrate in this case. So looking at the well, looking at the half-mile radius, and seeing, is a percentage of ag land less than 25%, 25 to 50, 50 to 75, or greater than 75, we see a pretty clear relationship that as the percent of ag cover goes up, the nitrate concentration goes up. And then because Chippewa County has sampled, done extensive sampling in 2007 and 2016, we can look at how did the samples collected in 2007 compare to 2016. The graphic on the bottom here shows the 2007 concentration on the x-axis, the 2016 concentration on the y-axis. And if the concentration was exactly the same in both years, it should plot right on that red line. You'll notice that there's a number of dots above that red line which indicate that they've increased over that time. There's also a fair number of dots below the line which indicate a decrease. The overall data would suggest that on average, nitrate concentrations in Chippewa County have gone up by about 1.2 milligrams per liter in terms of the aggregated average for the county between that time. Also, the percentage of wells that exceeded 10 milligrams per liter went from 12.3 up to 18.3. So the question is, does this constitute a trend? And we can say that groundwater quality has changed between those 2 years, but we don't know what happened in between that time period to say if this really constitutes a trend. What we can say is that groundwater quality is different, and that specific wells, we can actually say which wells are different, but we don't know if this represents a true trend in the sense that it's been increasing steadily over that entire time period, or maybe these individual wells go up and down, and we just happen to sample during a time period when they've been up. Maybe it's some sort of climatic variability. Maybe it's related to some sort of land use decisions. But it's difficult to say with any certainty that this is a trend that's going to continue increasing over time. So in order to get at the question of that, you know, our water quality or groundwater wells increasing over time, there's another strategy that we've developed with the town of Lincoln and Kewaunee County. Kewaunee County makes the news a lot. If you listen to the news, it might sound like all of Kewaunee County groundwater quality is bad. And really, there's key areas in Kewaunee County related to karst geology, which make particular areas very prone to nitrate and bacteria problems. One of those is the town of Lincoln, which is outlined in that black box. And here we initially tested 10 wells monthly for 1 year. This helped us understand how variable groundwater or well water quality is throughout the year. And once we did that, we expanded our sampling approach to 25 wells and cut back the sampling the sampling period from 1 month to twice a year. So county staff, in particular Davina Benes, who works for Kewaunee County, goes or visits these wells twice a year, once in January, once in June, to collect a sample. And then we analyze them and have been looking at that data to try and understand how groundwater quality in that town might be changing. And what we found from that, we've just hit 5 years, and we feel that 5 years is probably the minimum number of years of testing we needed even to try and start to look at that question. The goal is to collect at least 10 years of data and hopefully more. But what we've learned from those 5 years is that while individual wells may show trends or fluctuate, the overall water quality does not look like it's gotten significantly better or worse in the past 5 years. So the summary would show that 3 wells indicate an increasing trend, 2 wells showed a decreasing trend, 11 wells were relatively static, and then there were 8 wells that went up and down, but didn't have any discernible trend associated with them. This information provides us with a good opportunity to look at what's happening around those 3 wells with an increasing trend or 2 wells with a decreasing trend. What's happening specifically around those wells that's contributing to those changes in groundwater quality? And in those areas where it's decreasing, maybe that's something we can replicate in other parts of the county to try and improve water quality. What I want to do is try and demo a little app that we developed for the town of Lincoln, which helps provide a little bit of transparency to that data that we're using to try and understand trends. So here's a little app that basically shows our 25 wells. Each well is on the x-axis, and the box plot represents the nitrate concentration over the time period that we've been collecting. So the bold black line is represents the median concentration, and then the boxes represent kind of the spread or the distribution of that data. We have for those samples, we have nitrate, we have chloride, we have alkalinity measurements that we've been taking. Nitrate's probably the one that people are most interested in, though, so I'll show additional ways that data is then demonstrated or visualized for people to understand. So in this case, this lower graphic, this linear regression, shows nitrate levels in well number 1 over the time period that we've been sampling. And here we have a regression line. We have a R² value, and we have a p-value, which gives us some indication of whether this relationship is significant or not. And in this case, in well number 1, this is an example of a significant increasing trend. It's not increasing very rapidly, but we can see that it's probably gone from somewhere in the 15 range and is maybe starting to approach the 20 milligram per liter level. If we just click through some of these other examples, well number 2 is actually one that shows a decreasing trend. And here, again, that relationship is significant, and I think it's easy to kind of understand that that's the case. Some of the other graphics are less clear. This is an example one which is maybe going up and down, but there's no discernible trend to say it's increasing or decreasing. The p-value is certainly not significant. The confidence envelope is pretty broad, indicating that we can't say with a lot of confidence that this has a trend associated with it. There's other wells, if we keep scrolling through, maybe it's static, maybe it's consistently right around 10 milligrams per liter. But visualizing the data, helping get this information out there, I think gives it a sense of transparency that allows for it to be more accepted and less of a mystery what the data is showing. I'm going to try transferring back to the presentation here. If I can do this. So finishing up, The last thoughts I'd like to just get out there, I didn't have a specific place to fit these into the presentation, but I really would, no matter who you work with, I'd really encourage people are doing groundwater monitoring to use labs that are state certified, because they have a lot of procedures in place to ensure that the data they're collecting is accurate. And then lastly, and probably more importantly, is just never underestimate people's interest in their water. If you're going to ask them to submit a sample or you want to collect a sample from them, it's really important that you have the educational materials to accompany that water test result. You want to make sure they get a copy of their water test result, and you want to make sure that they can understand what that means. And if they have questions, there needs to be somebody that they can go to try and get answers. One thing that came up that might happen to other communities, especially in areas where the data might be contentious, is people are going to want that information as soon as possible. We had open records requests for the data basically as soon as those samples came back to the lab. And it was really important for me to make sure that the first people to see those results were the homeowners themselves, rather than read about maybe the collection of results in the paper somewhere, or here at a county meeting, hear the results of those testing before the actual homeowners heard about it themselves. So those are some key lessons that I've learned, is one, that people are interested in their water, and also make sure that if you're asking somebody to submit a sample, make sure you're treating them with the proper respect, because the information sometimes is going to show something they were unaware of that might make their water look bad, and that's something that is important to do with a lot of respect. So with that, I'm going to end the presentation. If people have questions, we could maybe do a couple now. Otherwise, I'm going to leave my contact information up here, and would welcome the opportunity to chat with people in more detail at a future time.
Thank you.
I'll look at the chat bubble and see if there's any questions.
Thank you so much, Kevin. That was really excellent. I appreciate your thoughts on how best to do a monitoring program. I will just, because you're too modest to do so, I will make a plug that I think we've had a really good experience with UW Extension and through your lab, and I think one of the benefits is that educational component that you bring. You usually, correct me if I'm wrong, usually with if people go through your Center for Watershed Sciences lab, you often follow up with the community educational program. Is that correct? Is that standard, or is that negotiated at a time?
The interest in well water testing is really high right now. So we try to do a set kind of 15 programs a year, and actually our calendar is pretty filled for 2019 already. But within that, those 15 programs, we agree to do the testing, the follow-up program, the mapping, the educational program in those communities. We would welcome the opportunity to work with more communities. It's just we might not be able to commit to the mapping. We could maybe do smaller testing programs, but we might not have the capacity to come out and do the full-scale educational program. We want to accommodate as many communities as we can, but with the limitations in outreach resources, we have to be strategic in where we and how we deploy those. So we tend to give priority to those communities that contact us in advance and get on the calendar, so we can fit them in our schedule.
Great. Thank you. Does anybody have any questions for Kevin? Or I don't know if Kevin, if you're seeing anything in the chat box
I'm not.
specifically to you, but if you have any questions, please put those into the chat box, or feel free to unmute yourself and ask them as well. I have a couple minutes to see if anybody responds. Questions? Okay. Well, again, if you do have any questions, feel free to contact me at Christina@wisconsinlandwater.org, or Kevin's got his information up, and we'd be happy to respond to you or redirect your questions. Oh, there's somebody.
Oh,
Thanks.
thanks, Chase.
Okay. Well, great. Thank you so much again, Kevin. Again, this will be recorded, or this has been recorded, and we will be posting this on our website soon. So thank you all for joining us. If you have any other additional topics that you would like more information on, let me know, and we will try to get those scheduled.